All right, today we've got a quick recap of our transformation matrices. First off, now we saw this translation. We add or subtract a matrix to get a translation matrix. Now let's say we're going to take our coordinate matrix. Now I've got coordinates A, B, C. The top row represents our x values. The bottom row represents our y values for each coordinate. So A is at position 1, 0. B is at position 2, -1. And C is at position 4, 3. Let's say we're going to translate this matrix right 2 units and then up 3 units. We would be adding the translation matrix. Now, because we have a 2 by 3, our addition or subtraction needs to be adding a 2 by 3 matrix. The first row, the top row, represents the x values. And since we're going to translate the 2 units right, we're going to add 2, 2, 2. We're going to up 3 units. The second row represents our y values, so we're going to add 3, 3, 3 is going to be our translation matrix. Whatever motion happens horizontally is going to be in the first row. Whatever motion happens vertically is going to be our second row. So we're going to add this to our initial matrix, whatever that is, -1. And we get our image. We're going to add corresponding elements. 2 plus 1 is 3. 2 plus 2, 4. 2 plus 4, 6. 3 plus 0, 3. 3 plus -1. And 3 plus 3, 6. This would represent A prime, B prime, C prime. Do this in red. We have now the coordinate 3, 3. 1, 2, 3. 1, 2, 3. That is A prime. B is moved to 4, 2. And C is now at 6, 6. 4, 5, 6. We have a translation. So whatever we're translating by, we fill the top row by that many units, fill the bottom row, the y values, by however many units or whatever magnitude that we are shifting horizontally, vertically. Next, we recap our reflections. We have a horizontal reflection, a vertical reflection over the x-axis. We have a horizontal reflection over the y-axis, and we'll have a reflection over the line y equals x. Reflections, rotations are going to be matrix multiplication. Now we have a 2 by 3. So we'll need to be multiplying by something that has 2 columns. I'm going to multiply on the left to get things to line up. Now, we're keeping, since we are reflecting over the x-axis, we're keeping the x value the same, and we're negating the y value. So our reflection matrix over the x-axis, a vertical reflection, is going to be 1, 0, 0, -1. When we multiply, remember, row by column, it's going to give us a 2 by 3 matrix, because 2 by 2, 2 by 3, the inner dimensions match, the outer dimensions give us the product matrix. So row by column, we have 1 times 1 plus 0 times 0. We have 2 times 1 plus 0 times -1. We have 4 times 1 plus 0 times 3. Notice that the horizontal values stay the same. For the second row, we have the second row, first column, 0 times 1, 0 times -1, 0 times 2 plus -1 times -1, 0 times 4 plus -1 times 3. And we see that the vertical components, the y values of each coordinate, has negated. The point 1, 0 stays the same, reflected over the x-axis, makes sense that it's not the same. 2, +1, and 4, -3. We have our vertical reflection. Horizontal reflection will be similar, but our reflection matrix is now going to be -1, 0, 0, 1. I think about this as Horizontally, we're staying the same, negating. Vertically, we are staying the same. Again, 2 by 2 multiplied by a 2 by 3. Reflection over the y-axis, a horizontal reflection. We have our reflection matrix -1, 0, 0, 1. Row by column, we'll have -1 times 1 plus 0 times 0. -1 multiplied by 2 plus 0. -4 plus 0. Vertical components, we have 0, 0 plus 0. We have 0 plus -1. We have 0 plus 3. Notice that the vertical components have stayed the same. This time the horizontal components have exchanged, have negated. That gets us a horizontal reflection over the y-axis. So we can see that -1, 0, -2, -1, -4, 3. Relative to our initial value, initial set of points, our image is now a horizontal reflection. I'm not going to graph the next one because I'm going to overload that, but a reflection over y equals x. Thinking back to inverses, inverses had a reflection over y equals x. What happens was the x's and y's switch. The y becomes the x becomes the y. The reflection matrix is going to be 0, 1, 1, 0. Notice that the first row and the second row exchange now. 1, 2, 4, 0, -1, 3. Checking the multiplication, we'll have 0 plus 0. We'll have 0 plus -1. We'll have 0 plus 3. Second row, we'll have 1 plus 0. 2 plus 0. 4 plus 0. We see that a reflection over the y equals x, the horizontal and the vertical pieces of each coordinate exchange places. Seeing that done out, 0, 1, we have -1, 2, and 3, 4. It looks something like that. You can see that is approximately a reflection over the line y equals x. If I actually had a coordinate graph, it would look better. Last, we have some rotation by some angle theta. Let's say I want to rotate my matrix, my coordinate matrix, by 60 degrees. I'm going to take this and spin it around the origin, around some point of rotation, 60 degrees. Well, we're going to do this is every single time our rotation matrix is going to be cosine the angle, negative sine of the angle, sine of the angle, cosine of the angle. Multiplied by our coordinate matrix. 1. This gets a combination of the horizontal change as well as the vertical change. And still, 2 by 2, 2 by 3, the multiplication lines up. So I'm saying 60 degrees. We'll see this done out. So we'll have cosine 60 degrees. I'm going to input and then switch to our values. Negative sine 60 degrees. We have sine 60 degrees, cosine 60 degrees. I'm picking these values, going to substitute with our known values of the unit circle. Cosine of 60 is 1/2. Sine of 60 is root 3 over 2, so that is negative root 3 over 2. Sine of 60 is, again, root 3 over 2. Cosine of 60 is, again, 1/2. So this becomes our rotation matrix, and we multiply by our coordinate matrix. Doing the multiplication, 1 times 1/2 plus 0, 2 times 1/2 plus negative 1 times negative root 3 over 2, that's 1 plus root 3 over 2. 4 times 1/2 is 2 plus or minus 3 root 3 over 2. Now, we could get some decimals so that we could more easily substitute in and graph this. Going on to the next, we have 1 times root 3 over 2 plus 0. That'll be root 3 minus 1/2. And lastly, 2 root 3 plus 3 over 2. So, A prime, B prime, C prime, that becomes the new coordinate for A, that becomes the new coordinate for B, that becomes the new coordinate for C. Just writing that out, we'll have and again, if we were actually graphing this, I would get a decimal for that, just so that it could be easier to plot. We've got our 3 coordinates after they have been rotated. Graph that out. There we go.